Hello, everyone. So I hope you did well on the test that you just took. So in this kind of session, I'll try to do any question I will able to do in the time that I have. So let's start with the first problem, and then I'll try to skip too much details explanation. So maybe I'll try later on some other approaches if I find another way of doing some question. But for now, I'll just do my first approach what I have for each question. Okay. So if you do have some other ideas, go ahead and share your comments like in the comments below, so you can always welcome to share your stuff. Okay. Anyway, so let's see the first one. So the A and B both live in AC. Okay, and then A and D leaves the city on his bicycle at 1:30. Okay, and then traveling due north with 8 miles per hour. But the same like Betsy leaves on her bicycle from the same point at 2:30 due east. That is 12 miles per hour. At what time will they be exactly the same distance from their common point they started? Okay, so the first things first, the person Andy will actually take 1 hour like distance, which is since the speed is 8 miles, so that should be 8 miles ahead, right? And then after 1 hour is just now 2:30. And then since they are going 8 miles and 12 miles, so they will actually take the 12 minus 8, which is 4 miles per hour. The Betsy will actually kind of catch up like 4 miles. But in total, that person like Betsy should take 8 miles, so that should take about 2 hours. From 2:30, 2 hours will be 4:30. So that is the number one, which is kind of easier. And the second one, we have a box contains 10 pounds of the nuts mixed 50% peanut, 20% cashew, and 30% almond. I'll kind of start with this way. So I'll say peanut and cashew, and let's say this is almond. So like 50% of 10 is 5, 20% of 10 is 2, and then 30% is 3. Okay, and the second box contains 20% peanut, 40% cashew, 40% almond is out of the first box. And the new mix will have 40% of peanut. How many pounds of the cashew are in the box? Okay, I'm going to call that kind of x. And then if I have the 40% peanut, which is going to give us 0.4x. And, right, so let me double check. No, actually 20% peanut. So 0.2x. And then 40% cashew, so that is 0.4x. And then 0.4x is going to be almond. And at the end, we do get 40% peanut overall, right? So that means I just need to think about these two. So when you add 5 and 0.2x, that is the peanut amount. Compare the total was like the 10 from the first one, and then x from the second box. So that's basically total. Has to be 40%, which is like 2/5, right? 40 over 100, that's 4 over 10, which is 2/5. And if I do cross multiplication, so you got 25 plus 1x equals 20 plus 2x. It looks like x should be like just 10, just 5. And the 5 is option, which is choice D. But we want to be careful because we are looking for the x was the total number of pounds of the entire mix, right? We are looking for the cashew amount, which is just this part. So you got 2 plus 0.4 times 5, which is going to be 2 plus 2, which is 4. Okay, so that is choice B. Okay, so that was not too bad either. So number 3. So how many isosceles triangles are there with the positive area? Those side lengths are all positive integer, and then the longest side is 2025. Okay, this is just a triangle inequality. So like think about the cases. Like we have, I'll say maybe case 1, I should say. We have 3 sides, but 2 sides are equal. And then 2025 is one of the sides, and which we are told that's the longest one. And let's say this is the base is 2025, and then this is x, and this is x. Since this must be the longest side in this like either option. So let me write that as my first condition. And the second condition, to get the positive value, we need to have the like triangle inequality satisfied. So, and then when you take any size, let's say 2025, and this has to be in between the difference between the other 2 sides and the sum of the other 2 sides, which is like the difference will be 0 and the sum will be 2x. And this doesn't make sense anytime. So, but if I take it divide by 2, so you get 1012, and 1/2 is lesser than x, which means x should be anything larger than this number, which is like 1013, 1014, 1015, so all the way till 2025. So this is the numbers from here. So I'm going to kind of count this after my cases 2, maybe, or maybe there will be some sort of overlapping. So let's say the case 2, and you can kind of do the same thing with the drawing if you want to, but you don't really need to. I'm going to just draw it for now because that will make it a bit easier to So let's say this is X to C. So then this is going to be 2025, and this is 2025. Again, in this case, 2025 is still our largest like side, so which means X should be lesser than 2025 or equal to. And by the triangle inequalities, if I take this side as my concern side, so the difference between the other two is 0, this sum will be 4050. So which means X should be in between these, but at the same time should be lower than this. So when you combine these two, it has to be in between 0 to 2025. Okay, so, in this case, like we have the answers like 0 to 2025 from here. So that will be like 2025 triangles because 1 through 2025. And in the first case, if you had the first 12, like first 112 numbers out of first 2,500, so you can say 2025 minus 1,012 because we haven't seen that many integers from this first list, so that should be 1,013. So this is going to be number of triangles from the first case. This is the number of triangles from the second case. So if I add those, so we will get 2025. So you get 38, and then you got 30, 38. So, this is actually not one of the choices, which is actually great, because, if there was a choice, maybe I may choose that answer, but it's not the case because in the first case, 2025 was one of the answers. In the second case, 2025 is also, so which means that it's actually overlapping. So we should have one lesser, which is choice D. Okay, so number 4 is a team of students is going to compete against a team of teachers, and the total number of students and teachers is 15. And then Ash is a cousin of one of those students who wants to join the contest. If Ash plays with the student, average age on the team will increase from 12 to 14. If Ash plays with the teacher, the average age will be decreased from 55 to 52. Okay, how old is the Ash? Okay, so this is kind of slightly challenging maybe, but let's see what we can write as equation. So I'm going to call the number of students is like S. Okay, so that's a S, and then teachers maybe T. I can do that, but let's actually use that number as 15 minus S. So we can get less variable. Okay, and then, if I want to consider the age sum before and after the person joins, that might be helpful. So let's say we have 12 students at first, right? So the average was, the number of students like S, the average was 12. So if we multiply 12 by S, this is the sum of their ages. But when the person A joined this group, that will be sum of their ages. And then in that case, the average will be 14, but the number of students right now is going to be S plus 1. Okay, so that is something. I can subtract 12S from both sides, so you get 2S, and then A will be equal to 2S plus 14. I guess that should be right. Okay, let's do the same thing with the teachers. So the average was 55. Okay, but the number of teacher was like 15 minus S. And then when the person A joined to the teacher, so we'll get the sum of their ages. But now the average became 52, but the number of people in that group will increase by 1. This was the number of teachers, so if you increase by 1, so you got 16 minus S. So maybe numbers are kind of a bit bigger, so maybe I should use just the T and deal with that, so I don't have to multiply 16 by whatever, but anyway, so I'll just do it. So then I'm going to multiply 55 times 15 minus 55S plus A equals 52 times 16 minus 52 times S. I think I'm right. Okay, and then I have A right here. So, this is 55, 15. This is 52, 16. Maybe I can split this as like 55 times 15 minus, I'm going to write this as 52 times 15. And then that will be like one more 52. So you will get minus 52. Okay, and that will be equal to, negative 55S, negative 52S. If I add this to both sides, so you got 3 times S, I guess. And when you do subtract these two, 55 and 52, that's 3/15. So the A plus 3/15 is 45, minus 52 is equal to 3S. Okay, so the A is equal to, this is negative 7, right? So 7 plus 3S. Okay, so now we can solve the system because I have this equation, I have this equation. So they are both equal to A. So the 2S plus 14 is 7 plus 3S. So the S will be 7, which means the number of students are like there was like 7. And teacher should be 8 then. Okay, and what we are looking for, the age for the Ash. So like, I think the rest is kind of easier. So because the A was equal to this or A was equal to this, so I can use this one. So the 2 times 7 plus 14, that's 20, right? So that's choice A. Okay, I hope that wasn't too long, but that was maybe the wordy. So that was number 4. Okay, number 5 is the sequence is given as positive integer, and then we are looking for the 25th term of this sequence. Like, these are actually questions that I usually don't enjoy much, because if you are actually missing one of the numbers off by 1 or 2 and stuff, you are easily going to get this wrong. So, but let's see what we have first. So we have 1, 2, 1, 2, 3, 2, 1, and then 2, 3, 4, 3, 2, 1. Yeah, it looks like we start with 1, and then we increase till 2, and then we got first 2, and then we start with 1 again, and then increase and then decrease all the way to the 2. I want to kind of start with all the ones. Let's see. So we have 2 numbers right here, and then we have 4 numbers right here, and then if I want to go all the way here, so you got 1, 2, 3, 4, 5, 6 numbers right here, and then if I continue in this, I should expect 8 numbers. 1, 2, 3, 4, 1, 2, 3, 4, which is 8. Okay, so yeah, that is actually nice. And then we are gonna have 10 numbers, and we'll continue. So the number of, like, I guess, integer in that list, or a number of like integers, I will say, is increasing by 2 every time, which is even number. But I'm just gonna add this 2 integer right here, 4 right here, 6 right here. So you can write this way. Actually 8, and then 10. So like it will continue, right? So, but I don't like adding evens. Maybe I can pull that too. So you get 1 plus 2 plus 3 plus all the way to the end. And then when you add these, we want to get something smaller than or equal to 2025. That's the goal. And I know this is the Gauss formula, so you can apply. So 2 times n plus 1 over 2. This has to be at most 2025. So these will cancel. And then knowing your like the prime factorization of year is good. 2025 was one of the easy numbers actually, which is 45 squared. So because this is 2 numbers that's really close to each other, so if I take 45 for this, that will be 46, so it doesn't work. But if I want to go with, like, say 44 and times 45, this is actually 1 lesser 45 from this number. So which means if you just subtract 45 from 225, you get 11980. So they easily get that number without really multiplying. So meaning that if you actually have n as 44, the sum of the numbers right here is going to be 1980, but we just need 2025. So like, think about this way. So we have the integer like this, and the last number is 2, and then we got this number to be 1980th, I guess, integer in that sequence, in that list. And then the next numbers will have our first, and then second, and then 3, and it will continue that way. And then we are going to get 45 numbers. But you know, when n is 44, you know, make sure you multiply this by 2. Your last number in this list, let me kind of highlight this a bit differently, 2, 4, like 6a. When you do this, the last number will be 2 times 44, which is 88, which means when you list this way, you're going to have actually 88 numbers in the last kind of group of the integers. So that means the new number, like the new list, will have 90 numbers. So, but if you have 44 will be the largest number in that sequence. And then in the next sequence, start with 1, the largest number will be 45. And then we just are going to start with 1 and then increase this all the way to the 44 and then 45. And then we will decrease again, 44, 43. Since we are going to have this 90 of these numbers, but we don't really need that much. We need only 45. So when you start with 1 all the way to the 45, you actually end up getting 45, which is choice E. So I hope that's clear. So I think this question can be done a lot of different ways, but at least this is what I have for now. Let's take a look at the next one. And the equality triangle, each interior angle is trisected, okay, by a pair of rays. And the intersection of the interior of the middle 20-degree angle at each vertex is the interior of the convex hexagon. Oh my goodness. Okay, what is the degree measure of the smallest angle of this hexagon? Okay, it's not clear to me yet. So let's take a look at this. I'm going to draw a bit bigger equality triangle. Okay, so let's say this is my triangle. It says each interior angle is trisected. So let's say one of this right here. And then let's say this is the second one. And then we will do the same thing. Something like this. It's already getting messy. I hope it will not be too bad. Okay, so let's label the 20 degrees. So this is 20, this is 20. These are 20. Okay, and the intersection of the interiors of the middle 20-degree angle at each vertex is the interior of a hexagon, convex hexagon. What is the degree measure of the smallest angle of this hexagon? Okay, so basically it says that, like, we take this segment, or you can say this is like ray, and then you have this ray. When you connect with this ray, so you do have some intersection. So this is like 1, and then this is 1, and then this is 1, this is 1, this is 1, and this is another one. I think this is the one that they are interested in, this convex hexagon, and we are looking for the angles of these part. So, okay, so one thing we can immediately say, in this triangle, if I really want to label it, so let's say this is ABC, and I'm going to call this, let's say T, I don't know, let's say L, M, N. It doesn't matter. So let's say these are stuff. So like in the XTC, we have 20 here, 20 here, that's 40. So that means the T has to be 140. And that means this is also 140. So it looks like we have 140 for sure, which is not the smaller for sure. But if I want to look at the A and C, so that is 40, that is also 40, that's 80. So that means N has to be 100. So it looks like we can immediately cross these two. And I think the same story will continue, because if you kind of think about this part instead of the AC part, like 20 plus 20 is 40, so the M will be 140, so that means this will be 140 as well. And then similarly, I will get this guy to be 100, and then the other two will be the same. So which means we have only two angles actually, 100 and 140, and the smallest one is 100. So it was a bit interesting problem, but I think that wasn't too bad. Okay, so let's see the next one. So the number 7 is we have A and B, two real numbers, and the polynomial is divided by x minus 1, and the remainder is 4, and then the same polynomial divided by x minus 2, remainder is 6. Okay, it's actually easy because this is just a factor theorem. If you do know, if you divide this by 1, so that will tell us P of 1 is going to be 4. And if you don't really get this one, I'll say just really study on the factor theorem and remainder theorem, because this is really basics of that. And then if you divide by x minus 2, that means P of 2 has to be 6. And I can just plug those numbers. So if you plug 1, so you get 1 plus A plus B is equal to 4 from here. So you got A plus B is 2. If I plug 2 for x, that will be 8 plus 4 plus 2A plus B equals 6. So that should give us 2A plus B is actually -6. Okay, so we can subtract the first from the second equation. So you got A equals -8. And if I plug this A right here, -8, so add 8 to both sides, B is 10. So we are looking for B minus A, which is 10 minus -8, so that's 18. Okay, so that was number 7. Okay, number 8. So the person writes the following 4 statements, and each statement is either true or false. How many false statements are actually written? Okay, this is kind of the question is also a bit challenging, especially in the time of the test. You don't really kind of understand, and then you get confused with each statement because of the wording. But like, here's what I usually try to do, this kind of stuff. Even though this is kind of wording problem, I try to make I'll say some sort of equation. So let's say the T is the number of true statements. Okay, and then the false is the number of the false statements. Okay, so, and then we are going to write some sort of inequalities. The first one says at least one of the statements is true. Let's assume all of these are kind of the statements are correct, and then we're going to just see some sort of consistency. At least one of the statements are true, which means T is going to be at least 1, but it could be more than 1 as well. In the second one, at least 2 statements are true, which means T should be larger than or equal to 2. And then at least 2 statements are false, which means F has to be at least 2. It could be 2, 3, or 4. But in this case, if you have at least 2 false, that means the true should be lesser than or equal to 2. So they are going to require each other. So, and then the last one, at least 1 statement is false, which means F is larger than equal to 1. If you have at least 1 wrong, that means the true should be less than or equal to 3. Okay, so this is good. So now we're going to kind of like do the case. Like I can start with 0 all the way to the 4, which is okay. But I usually try to start with the true, like middle guy. So let's say T is 2, right? Which means there are 2 correct statements. So in that case, the first one says T is larger than 1. So that is a good, so that's correct. And then the second statement says T is larger than or equal to 2, which means 2 is also okay with that. That's 2 correct. And the next one, F is larger than or equal to 2, but true, T could be 2 as well. So that means that is also a yes. But we already have 3 truths, but in this case, it has to be 2. So that is not valid. So we can easily cross this one. And then you can go this way or that way, so which doesn't matter, but let's go with 3. So if I go with 3, so which means T has to be 3, which means this is actually correct statement. And then this is also correct statement. And in this case, T is lesser than or equal to 2. There's no way to get 3 in this case, so that is false. And then T could be, T has to be lesser than or equal to 3. So that means this is actually also correct, right? So that means we already have how many? 3 correct and 1 wrong. So which looks like this is correct. So I'm going to say we do have 3 correct statements. If you have 3 correct statements, then we should have only 1 false statement, which looks like B. But for the sake of confirming, we can check the other ones as well. Let's say t is 0, which means there is no correct segments. If t is 0, that is no good because t has to be at least 1. And then if t is 0, that doesn't work either. And then in this case, t could be less than or equal to 2, so that is yes. And then t could be less than or equal to 3, that is also yes. We have 2 correct, 2 wrong, but it has to be 0, so that's no good, that's not consistent. And you can try 4 as well, but I'm not going to do that for now, so you can just check that as well. So that was the answer. Okay, so number 9. So the f of x is given, and okay, it's a cubic. How many real values of a does this graph of y f of x minus a pass through the point 1, 25? Okay, so maybe we should graph it, but the first thing I see immediately, like this is not a bad polynomial because we have 100 and then x is a common factor. So maybe we can pull that first. See the 100x times x squared minus 3x plus 2. Okay, and then this looks like a factorable, so that should be x times 100 times x minus 2, x minus 1. And then I can even find the zeros and graph it. So let's try that. Okay, so we have 0 as 0, 1, and 2. So we have like 0, 1, and let's say this is 2. And if you start with a positive, like negative numbers or positive numbers, maybe you can kind of think about this one. So like if you choose x is like negative number, this is going to be negative. So when you are choosing so like small numbers, you're going to get negative numbers. So your graph might be look like, I don't know, like something like this. And then when you hit this, you just go above the x-axis. At some point you go down, and then you go up again. So it's just the behavior of the graph. So because all these zeros are multiplicity of 1, so they have to go through the x-intercept. So that looks like we have 3 real solutions in a way for the given function. But we are looking for the y equals f of x minus a, which means I can plug this into this function. So the f of x minus a should be 100 times x minus a times x minus a minus 2, x minus a minus 1. But this is actually not really different from the previous one. Actually, I don't need to simplify anymore. Okay, so like this is actually just the translated version of this graph. So there's not really much changing in terms of the roots. Since this has a 3 solution, so this has to have a 3 solution as well. So I'll say 3 solution will give us the same 3 A's. So like if you're not kind of satisfied with that, so you can make this slightly longer solution. But since this is number 9, I wouldn't really bother that much. But I will say if you are not convinced with that, so you can always try kind of setting like some sort of equation like this. Let me say if you want to say this is maybe like t as like, I don't know, you can make some sort of like you can plug 1 and 25 first, like that will be 25 equals f of 1 minus a, right? And then you can just say plug this guy as t. Let's say 1 minus a is equal to t, and then replace right here, so you can get something in terms of t. So that will be way better than this looking. So the f of t, I will say, could be written like 100 times this will be 1 minus a, which is t, and then this will be 1 minus 2 minus a. So you can just replace those and multiply all these. When you multiply those, you actually can expand and get a polynomial in terms of the t in the 3rd degree, which will have possible 3 solution. So we can immediately cancel these 2. And then as soon as you got that polynomial, you can kind of try checking some integers or rational numbers based on the constant to get some sort of interval to see if you have some sort of y values changes. So that's going to tell us there will be some roots in between those 2. So anyway, so you can try those. And then if you do so, I hope you will get the same 3 as well. But I'm confident with this number, so I'm going to skip for now. But if that doesn't make sense, maybe I'll make more video on this problem to make sure we are on the same page. Anyway, number 10. Okay, this is actually interesting looking, but it's actually not too bad, I hope, because I've seen this question a lot. So this semicircle has diameter AB, so from A to B, chord CD, and then chord CD is 16. The smaller semicircle with diameter AB, with diameter on AB and tangent to the CD right here, cut from the largest semicircle as given. What is the area of the resulting? Okay, so like whenever you have this kind of step, you can always find the center, even though it doesn't really say where the center looks like. But based on the drawing, I will say somewhere here might be my center. But before we kind of do this, maybe I should say the radius is like r, and then radius of the smaller one is, let's say this is r. And then what we are interested is 1 over 2 times pi times r squared minus 1 over 2 times pi times r squared. So that will give us pi over 2 times r squared minus r squared. I think we've seen this kind of question a lot, especially if you did some mid counts even, when you have the tangency on a circle. So if you can find this one somehow, then the rest is done then. So the first thing we always love doing it when we deal with the circles, just take the center and connect with the intersection. And then if you have a chord, then drop the altitude from the center to chord, because that will bisect. So that will make a right triangle. So that should be 8. And then this r, since this is also tangent here, since this is r, this is also r. And if you use the Pythagorean here, the r squared minus r squared will be 64. So that is 64 times pi half, which is 32 pi. Okay, so that was number 10. Okay, number 11 is the next one. Okay, the sequence 1 x, y, z is arithmetic. Sequence 1 p, q, z is geometric, and both sequences are strictly increasing and contains only integer, and z is as small as possible. What is the value of the sum? Okay, I'm gonna write z in terms of the common difference and the common ratio, because that's what we really care in this case. So since we are gonna increase 1, 2, 3 times, the z is equal to 1 plus 3d. The d is the common difference. But the z is also, we are going to multiply this 1, 2, 3 times. So the 1 times common ratio to the third power. So from here, so we are told 1 plus 3d is equal to r to the third power. Again, we are trying to like optimize the z to get the smallest number. So you can kind of guess the r since they are all integers. So the 2 cubed is 8. So 1 doesn't work. So that's 8. But when you take the 8, so that should be 8 minus 1 is not multiple, so it's not going to work. So the 3 cubed will be 27. That's already multiple 3, but there's plus 1, no good. So the 4 cubed is 64. I think it does, because that 63 is multiple of that. So meaning that r has to be 4. And then the d is 21. Then we can just find everything else. So we have the x is like 1 plus d, which is 21 more. And then y is 42. No, that's 22 actually, because 1 plus 21 plus 43 plus 64. And then p is the first number when you multiply 1 by common ratio. Common ratio was 4. So you got 4, and then 4 times 4 will be 16. Okay, so we got 64 and then 16, that's 80. So you got 120, 127, and then you got 147 plus 2, 149. Let's try C. Okay, let's go. The number 12. Okay, so see what we have with that. So it says the Carlos uses 4-digit passcode. Okay, and it's unlike his computer. And in his passcode, exactly 1 digit is even. Okay, I'm gonna highlight that. So exactly 1 digit is even. And exactly 1 possibly different digit is a prime, and then no digit is 0. Okay, this has a lot of condition. And how many 4-digit passcodes satisfy this condition? Okay, so the first thing maybe we should try is kind of start with the restriction and write the cases based on that. So that's what we usually try, right? So the one thing is, we cannot use zeros. Let me write the evens. So the evens like 2, 4, 6, and 8. And then we have odd restriction. So that should be like, actually, no, not odd restriction, the prime restriction. So that should be like 2, 3, 5, and 7. I will say the other. So we did not use 1, 2, 3, 4, 5, 6, 7, 8, and it looks like 9. Okay. So one thing is like, let's start with 2, because 2 is the number in both cases. I want to say case 1. Let's say 2 is used. Okay, so in that case, 1, 2, 3, 4. If 2 is used, like the even condition and the prime condition are used, right? So, but I do have 4 spot for 2. Which one is going to be, right? So I will say that is 4 choose 2. I can choose any spot for 2. Let's say we choose 2 here, right? So let's say 2 goes here. And now for the other spot, we cannot use any other prime because we have exactly 1 digit prime. So 2 is used. Then we cannot use any even either. So because 2 is used. And then since we cannot use any of these evens, any of these prime either, so we should use only these 2. So we have 2 options for here, 2 options here, 2 options here, right? So it looks like we have 4 times 2 times 2 times 2, which is 4 times 8 is 32. Okay, I will check if I need to. So it looks like this is 32 cases. Okay. And then the second case, maybe even is something else. but the prime could be one of the other threes, right? Because we don't want to use 2 anymore. So I'll say 1, 2, 3, 4. So that is the second case. Okay, so let's say the even number, right? So we just need to get one of these. So we have 4, 6, and 8. So we have to choose one of these 3. So 3 choices. And then we need to choose one prime. So from the 3, 5, and 7. So you get 3 choose 1. As soon as you choose these two, let's say we choose 6 and 5, or 8 and 3, or 4 and 7, or 6 and like 7, whatever. So you just need to take 2 spots for those 2 numbers. 4 ways to choose the first spot for one of these numbers, 3 ways to choose another spot for the second number. And then we just need to complete the 2 more slot. So we cannot use any evens, any primes more, because we just use one of each. And then the other 2 spots left over should be 1 and 9. So we can use those 2. Okay, so it looks like we get 9. So you got 12 times 4. So you got 108 times 4, so which is going to be 432. Okay, so we have 432 plus 32, so you got 464. Okay, that was slightly challenging, but I think this question, not too bad, but it was kind of a bit challenging to list those. So that was number 12. Okay, here's the number 13. So in the figure below, the outside square contains infinitely many squares, and each of them with the same center and the sides parallel to the outside square. The ratio of the side length of a square to the side length of the next inner square is k. Okay, the ratio is k. Okay, k is lesser than 1 and larger than 0. The space between the squares alternately shaded as given, and the area of the shaded region is 64%. What is the k? Okay, so like basically, I'm gonna start with like say 1 for the side length, and this has to be the area, like the second one, since the ratio is k, so I will say this has to be 1 over k. No, this will be k, right? So let me just write that. This is k, and then this will be k squared, and then this will be k cubed, and it will continue. But to get the first shaded region, that will be 1 minus k squared, because the 1 is area of the largest square, and then k times k will be the second largest, so that is difference is the area of the shaded region. And if I want to do the second one, so we want to find the area of this square and subtract this one. So the k squared times k squared will be k to the 4th. And then the minus, this is k to the 3rd times k to the 3rd, which is k to the 6th. Then it will continue k to the 4th times k to the 4th, and then minus k to the 5th times k to the 5th. So you will get something like this. And it will continue forever. So this is actually a geometric series. So if you remember the geometric series, like when the k is lesser than, the common ratio is lesser than 1, the sum was a over 1 minus r. So in that case, the first term is 1, and then the common ratio you always multiply by negative k squared, so which means 1 minus negative k squared is equal to 64%. Okay, and then that will give us 1 over 1 plus k squared is equal to divide by 4 maybe, so 16 over 25. And then if I do cross multiplication, so you got 25 is equal to 16 plus 16k squared. And then that will be 9 equals that divided by 16. So the k squared will be 9 over 16, which is 3 over 4. Okay, so that was the answer for number 13. So I'm not trying to see all the comments, so I'm going to check those later. But for now, I'll try to do questions only because I cannot focus at the same time. Anyway, so the 6 chairs are arranged around a round table, and 2 students and 2 teachers are randomly select the 4 of the chairs to sit. Okay, and then what is the probability that 2 students will sit in 2 adjacent chairs and 2 teachers will also sit 2 adjacent chairs? Okay, so there are a couple of things we can do. First things first, if you actually do arrange things around a table, and if you have n people or an object, we actually can do this n minus 1 factorial ways. So I'm assuming you know this one. So then think about those 2 students. I'm going to call the S1 and S2. I'm going to take these two as one individual, and then teacher 1 and teacher 2. I'm going to take these 2 together as another individual, and then I will say O1 is other student, other 1, and then other 2. So it looks like we have 4, I'll say object, 4 group, whatever you call. And if you have 4, so you have like 3 factorial ways you can arrange those. But the thing is, you can arrange these 2 people around each other, so that should be 2 factorial, and the same thing with the teachers. This is actually your desired outcome. But if there was no concern, so when you have 6 table with 6 chairs with 6 people, you can have that 6 minus 1, which is 5 factorial ways. And this is actually what we are interested. So you got 3 factorial times 4 over 5 times 4 times 3 factorial. So these will cancel, these will cancel. So you got 1/5. Okay, so this wasn't too bad. I think we can do it a little bit differently as well, but I will move on. Okay, number 15. Okay, geometry problems. The ABEF is a rectangle. AD is perpendicular to ADE. Okay, let me write that AD. Actually, AD perpendicular to ED is given already. AF is 7, so this is 7. AB is 1. AD is 5. So the entire thing is 5. And then we want to find the area of the shaded region. So I probably need this BC. I'm going to call that X. And since you know the FA is 7, so that means EC is 7 minus X. I like to write anything I can. And since the angle right here is vertical angle, so they should be same. And then we have 90, so that's a good sign to see the similar triangle. So this guy and then this guy has to be same as well because they are complement of the right angles, right? So then these two triangles are similar, so we can write the ratios. But let's use a Pythagorean because the hypotenuse right here is given. So that means this is going to be x squared plus 1 under square root is the hypotenuse. And AD was given as 5, so which will make this guy 5 minus the AC. Which doesn't look fun looking, but anyway, so let's do that. So let's write the ratio. So the hypotenuse is x squared plus 1 over, on the radical, hypotenuse is 7 minus x, is equal to, and in this case, the side that is opposite the blue is known, which is why I'm going to start with the x right here, over the blue angle is opposite to 5 minus x squared minus 1. Okay, so that is not nice looking, but it looks promising. So let's cross multiply. So you got 7x minus x squared. And then if I multiply this by 5, so you got 5 times the x squared plus 1. When you multiply this by this, I think this was plus 1. So you cancel the radical, so you end up getting just a minus x squared plus 1. Okay, so since we have still radical, I'll pull this guy along, everything else on the other side. So this will be negative x squared, but there's negative x squared as well. Those will cancel. So you get negative 1. That's going to be added to both sides. So you got 7x and then minus 1 on the left side. Right? I mean, no, plus 1 because we add 1 to both sides. So that should be 5 times square root of this mess. Okay, so that looks not too bad because this is number 15. So let's square both sides. So you got 49x squared plus 14x plus 1 equals 25 times this mess, which is 25x squared plus 25. And if you subtract 25 from both sides, so you got 24x squared plus 14x minus 24. I hope I did not miss anything yet. So then divide by 2, so you got 12x squared plus 7x minus 12. Okay, so I'm hoping this is going to be factorable. Otherwise, I'll go with, I guess, quadratic formula. So what I will do, maybe we can try dividing this by 4 and 3. So let's say this is 4x and this is 3x. And then this is like minus 12. Middle guy is 7. So like maybe I can try 4 times 3. That's 12. That's also, let's say this is 4. And then this is 3. So that's 16. That's 9. The difference has to be 7. So maybe I can just do this negative and this is positive. I think it does work. Right? Let me double check. So 4x times 3x will be 12x squared. 4 times 4 is 16x, and then minus 9x, which is 7x. Negative 3 and 4 is negative 12. Okay. So then from here, this doesn't give us positive numbers. So the solution x is 3, 4. And then we are looking for the area of the triangle. So that should be 3, 4 times 1 times 1/2, which is 3 over 8. Okay, so it wasn't too bad, but the similar triangles are always nicer to use. So that was another time that we've seen. Okay, so the next number is number 16. Okay, so now we have like 3 jars. Each of the 3 coins is placed in one of the 3 jars, chosen at random and independently of the placements of the other ones. And what is the expected number of coins in a jar with the most coins? Okay, so far, this is expected value for sure. And we do have 3 cases, right? So we are looking for the expected number of coins in a jar with the most coins. So like, I'm gonna say, maybe we can start with like 1, 1, 1. So let's say this is the first case. 2, 1, and 0 in any order, or 3, 0, 0. So we have the 3 options. So let's say this is the jar 1, jar 2, jar 3, right? And in the first case, like first of all, the total possibility, like for each coin, you have 3 options, right? You can go one of those 3 jars, which is 3 times 3 times 3, which is 27. So you have 27 outcomes if there was no restriction. But in the first one, we just want 1 for each jar, right? So then, like, imagine the first coin going to one of the jars. Then you have 3 options for the first coin. And the second coin does not have 3 options anymore. We have 2 options because we cannot do this 2 in that. And the last coin goes to the empty one, which means the desired is the 6 ways out of 27 for the first case. I'm going to write this as 6/27. I'm not going to simplify because I want to have the same denominator, so I can add them easily. That's 6/27 for the first case. The second case, I do have like 2 coins will go to the 1, right? But the thing is, only 2 jars will be used in the second case. Maybe we can decide what 2 jars, let's say 3, choose 2 ways to decide what 2 jars will be used, which is 3 ways. And then we need to decide what 2 coin goes into that jar with the 2, right? Which is also 3, choose 2. And then there will be another one, which will be the single coin, right? So that is 2 options for that, because there's like 2 options that we can choose for. So that will be 2 ways. Let me double check. So we got the jar gets the pair, which is 3 ways we can choose what 2 jars will be getting those coins, which 3, choose 2. And then remaining, we just need to determine which one, which 2 coins will be actually going to this jar. So that's why 3, choose 2 as well. And then we just determine which jar will have 1. So the last will be the 0 then. I think that's reasonable. And then this is the desired outcome. So it has to be like 3 times 3 times 2, which is 18. Okay, so let me double check. Right, so that's 18/27. I think that should be good. Then this was 6/27. And the last one is the 1 jar will just get the all. So like, we have 3 options for that jar. So either this jar or this jar or this jar. So we have 3 options because the coin doesn't have any choices. You just need to decide what jar. So which we have 3 options out of 27. So that is just the case for the last one. If you combine them all together, so you got the total probability, but we just need to find the expected number. So we just need to multiply each probability by their value. So in this case, the highest number is 1. So we just need to multiply this by 1. And the second one, the highest number was 2. So you got 2 times 18/27. And the last one is 3 times 3/27. So you got 6 plus 56. No, not 56, 36. And then 9/27. So that's 45, 51/27 divisible by 3, which is 17/9, which is choice D. Okay, so that wasn't too bad, I guess. The number 17. So the n is the unique number, positive integer, that dividing the 27, 34, 36 by n leaves a remainder of 16. Dividing 27, 27, 60 by n leaves a remainder of 15. What is the 10th digit? Okay, so like, let me write the equation or congruency. 27, 34, 36 is going to be congruent to 16 if you divide by n. Okay, and then similarly, 27, 27, 60 is congruent to 15 if you divide by n. And then we want to find the 10th digit of n. Okay, so maybe we can subtract the 16 and 15 to get the zeros. So that might be useful. So if I take the 16 from the first one, so you will get the 27, 34, 20 is congruent to 0 mod n. And the second one will be 27, 27, 45 is 0 mod n. Okay, so basically telling us now this number is divisible by n and this number is divisible by n. So which means we are looking for the divisor of both numbers. So maybe we can find the GCD. So 27, 34, 20, 27, 27, 45. So like if I find the GCD, when you use a parenthesis with the order pair, that means GCD. So, and then we can use the Euclidean algorithm at this point to make these numbers smaller because they are too big. So the difference between these 2 numbers shouldn't be too big because this is 27 and this is 27 already. So let's take the difference. So 20, actually I can do it right here. Since this is larger than this one. So the difference will be like 0 minus 5 is just 5. And then you got 11 minus 7. 11 minus 47. So you got 3 minus 7, 13 minus that will be 6. I think that should be 2, and then that will be 0. Okay, so that should be 27, right? 27/45. So which means the GCD has to be a divisor of this number and this number. So because that's just the same as this one, when we just take the difference between these two. And since this is a lower number, maybe I should divide by these two numbers first, since they're both looking divisible by 5. So I'm going to divide this by 5. And if I divide this by 5, so you got 27 divided by 5. I can actually do this. 27 by 5 is 5. You got 2 left over. 22 goes to 4 times. And then you got 27 is 5. So 24 is 4. 45 is 9. And then if you divide this by 5, so you got 1, right? And then you got 17 is 3 times. So you got 25 is 5 times. Okay, so this is still divisible by 5, but this is not. And this is the sum of the digit is like 9. So I hope that's divisible by 9 as well. So that's 9. Yeah, this is also divisible by 9. So I can divide by 9. So you get 9 times 5. So if you divide this 54 by 9, so you got 6. And then you got probably 6 and 1. I can double check. And then you got the 1. That's 45, which is going to be 5. Again, this is divisible by 3 and 5, but this is not. So the GCD is just 45. What does that tell us? The number n has to be either 45 or any divisor of 45. But when you look at the divisor of 45, so you can divide by 3, which is 15, divide by 5, which is 9, and then 5, 3, and 1. So then since n will give us the remainder of 16, so we cannot have any of these. So 45 is the only number that actually works. And we are looking for the 10th digit. That is actually 4. Okay, so that was a bit challenging for sure. So the number 18. Okay, so we have now a harmonic mean. Okay, they defined the harmonic mean. Okay, that's good, because if I do know the harmonic mean definition, so the half of the question actually just nothing for me. So what is the harmonic mean of all the roots of the 50th degree polynomial? Oh my goodness, of this. Okay, so even though this looks like challenging, I hope it is not too bad. So let's understand the question. Like it says this is a quadratic. And then when you choose case 1, you end up getting this one. If you choose case 2, you end up getting the second one. If you choose case 3, you get this one. And if you choose case this number, you get the last one. But nothing is changing except the k, right? Maybe let's take a look at the roots of this expression. So the discriminant is like b squared minus 4ac. In this case, like negative 4 squared minus 4 times k times negative 3. So it looks like 16 plus 12k. Since the k's are positive integers, so this is going to be always larger than 0, which is good. Which means each quadratic, like this quadratic will have 2 different real solutions, which is actually nice. And then we are looking for the real roots of the 50th degree, so 4050th degree polynomial. Like to understand what's going on, they're asking this basically 4050, and then divide this by the reciprocal of the roots. Like if I call the roots like R1, so you got 1 over R2, and then 1 over R3, and then you will continue all the way 1 over R4050. And then that is actually the expression we need to simplify. But it's interestingly challenging, but at the same time, we don't really need to do maybe all of these, because if I want to just do each one of them, like as long as I know the sum, we are good, right? So like if I want to take the only first 2, and then the next 2, and then next 2, next 2, we'll continue doing that, and then we'll kind of find the denominator easily, right? So the first one, let's maybe do it here. So you got 1 over R1 plus 1 over R2 is equal to R1 plus R2 over R1 times R2. And if you know the sum and the product by Vieta, let's say we have a quadratic is equal to 0. Sum of the roots R1, R2 is equal to negative b over c. And then the product of the roots is the c over a. So that is just the Vieta. From here, so the sum is negative b over c, and then product c over a. So these c's will cancel. So you got b over a, right? Negative b over a. Okay, so then the first one, this guy will be just the negative b, which is negative of this number, that's 4, over a. A is 1. Let me double check. So you got negative b over, oh, this was negative b over a. This is c over a. Oh, I think I messed up with that. Okay, so that will be like negative b over a divided by c over a. So that should be negative b over c. Okay, let's go. So the negative b will be 4, and then divided by c. C is negative 3 every time. So that will be negative 4, negative like 4/3. But if I do the same thing with the next one, since my b and c doesn't really change in any equation, so then you always get the sum of the reciprocal up to the roots for each quadratic is just 4 over negative 3. And then since we have this 40/50 term degree, so that will be 25 pairs of the roots, so which means we have this 25 times. So the answer should be like 40/50 over 25 times negative 4 over 3. And then luckily, we can just cancel this. You got 2 times -3/4, which is -3/2. Okay, so that is choice B. Yeah, this was like, interestingly, kind of challenging looking, but I think this was actually easier than some of the previous problem. Okay, so the next one is number 19. Okay, so the array of the numbers is constructed beginning with the numbers -1, 3, and 1 in the top row. Each adjacent pair of numbers is summed to produce a number in the next row. Each will begin and end with the numbers -1 and 1 respectively. The first 3 rows are given. And if the process continues, one of the rows will have a sum of 12,288. In that row, what is the third number? Okay, so this looks like a bit challenging. So with this kind of question, we usually try to find a pattern. So since we are trying to find a sum, maybe let's add these numbers. So that will be like 3. And then when you add the first and the last one, you got 6. So you got middle 2 will be 6. And then when you add the first and last, just 0. So you got the middle 3 is 12. It looks like we are doubling. So let's see if that's really the case. So, if you want to kind of make a, I don't know, like generalization, so that might be useful. Just kind of convince yourself. Let me try that. So, and then we can kind of go from that path. So let's say -1 is the first number. And then let's say R0 plus R1. So again, R0 meant to be my previous row. Imagine there's a row. And then you got -1 as well. And then you got R1 and then R2 all the way to the Rn. So in that case, Rn is being 1, and then -1 means R0. Let's imagine this is the row. And the next row will be -1 plus R1. So R0 plus R1 basically. And then you add -1 to sides. And the next one will be like R1 plus R2. And then you just continue doing this, right? And the last one will be Rn plus Rn minus 1. And then the last one will be just 1 as before. So when you look at this one, you know the R0 was -1, but this is also -1. So you got 2 of that. And then R1 here, R1 here. So and all the middle terms will be double because you're adding these 2 for 2 times to get the next like numbers. And the same story will be going in the next one as well. So this was Rn, which is the 1, but this is also 1 because you start with -1 and +1 ending. So which means all of these actually happening twice every row. So which means the pattern was actually right. So which means you're always doubling when you add them. So then you can just say, we start with 3, and then you multiply by 2 some number of times to get 12,288. And if you divide by 3, so you will get 2 to the n. So 12 divided by 3 is 4. And then if you divide, let's say, 300 by 3, that's 100. But this is 12 lesser, which is 4 lesser than 100, so 96. And then this is actually a good number because if you remember the power of 2 is like 10 power will be 1024, so 11 power will be 2000, and like 10,000, like 1024. I mean, this is 12 power, right? So yeah, I think this is 12 power. So the n will be 12 because the 11 power will be 2048, and then 12 power will be 4096, which is good. So again, the n is the number of times that we multiply the first number, which means we are looking for the 13th row. Okay, so 13th row. And then we are looking for the third number in that row. So this is kind of progress for sure. But after this, let's see what we can do. So like we got these, and then we got these numbers, but how do I find the numbers in the 13th row? So like one thing I can usually say, try to write these in terms of polynomial if you can, and see, since every time we are just like taking the first one and then get the next one based on the first one, right? Maybe I can just use this as a like quadratic and then multiply this by a like binomial to get the next term. So let me try to see, like to show you what I mean by like, if I want to say this is like -1 plus 3x and then plus x squared. So like this is like my original one. And if I want to multiply this by 1 plus x, let's see what's going to happen. Like the reason I'm going to do it this way, this is kind of coming from a generating function. If you kind of don't know about that, so this might be a bit not clear to you. So I may explain that maybe details later on. But so if you try these two, you got -1, that's this guy. And then you multiply by x, which is -x. But when you multiply 3 by 1, that's 3 plus like -1, which is 2x. So you got that. And then when you multiply this by, like let's say this one by this, you got 3x squared, but there's another one, that's 4x squared. And then this one time, this will be x cubed, which if you look at the coefficient, -1, 2, 4, and 1 is actually these guys. So which means to get the next row, you actually multiply 1 plus x times, right? So if you want to find the 13th row, So you want to multiply -1 plus 3x plus x squared by 1 plus x 12 times. And then when you do so, you are looking for the third term, which means the term that you are like looking at has power of 2, because the first one has 0 power, second is like linear term, the third one is the quadratic. So then you ask yourself, I need to multiply the -1 by a term from here that has the second power. If you do remember the binomial expansion, so you will get -1 times 12 choose 2, because that will be just the coefficient, will give us the second power of the x. So from the binomial, and if you multiply 3 by the coefficient from here, that is coefficient of the x terms, which is going to be 12 choose 1 from the binomial theorem as well. And the last one is 1 is the coefficient of the square term. And then I need to get the constant from here. So that's going to be the first term, which is just 12 choose 0 or just 1. Okay, 12 choose 2, 12 times 11, which is 66, but we have minus. And then you got 12 times 3, which is 36. And then this is going to be 1. That's going to be -30 plus 1 is -29. Okay, this was interesting. I'll take a look at this question at some point to see if I can find another way of doing this one, but that is at least something we can do for now. Okay, so number 20, a silo, right cylinder, with a diameter 20 meters stands in a field. Okay, and McDonald is located 20 meters west and 50 meters south of the center of the silo. Okay, and then the guy, Greg, is located 20 meters east and some G meters south of the center of the silo. The line of sight between the McDonald and Gregor is tangent to the silo. Oh my goodness. Okay, there's a lot going on. So maybe I should draw something to visualize. I want to make a cylinder somehow. Okay, so let's say this is my silo. So I'm going to take this guy as origin, the center, and then what we are told, the diameter was 20. So this is 10. And the McDonald is located 20 meters west. So which is like, this is already 10. So you do get another 10 right here. And then 50 meters south. So it looks like maybe right here. So that should be like, if I take this origin 20 to the left, which will give us -20 and -15 because we went down as well. And then this is the M. Okay, and then the second, the Greg is 20 meters east, so which is just right opposite. And then some G. But at the same time, when you say like the line of sight between the McDonald and the Gregor is tangent to silo, so which means when you connect this point, then you draw a line that will be tangent, and then they will be connecting the other one. So with that in mind, so maybe it looks like this. Okay, so then it's basically, I hope this is G in terms of distance, and then the point, the coordinates right here is going to be like 20, -G. Even though I said G, but since I choose this is 0, 0, so since you're going downwards, so that should be -G as the coordinate, and then this is going to be tangent to this. So, and then I do know this has to be 90 degrees. Okay, this is cool because, when you do have like a tangent to something that are perpendicular, and I can find the distance, which is, we know this is 10, but I do need to know the equation in standard form. So let's go ahead and write the slope first. So you got the -G plus 15 over 20 minus -20, which is 20 plus 20, is my slope. Okay, and then if I want to write the equation, maybe point slope form because I have this point. So y minus the y-intercept, which will give us plus 15, right? And equals the slope, which is 15 minus g over 40 times x minus x-intercept. And then I'm going to multiply both sides by 40. So that should be 40y plus 4 times 15 is like 600 is equal to this times this. So like, I'm going to actually write 15 minus g times x and then plus 20 times this. Okay, it doesn't look like really nice looking, but I was expecting a bit better. Okay, so then you get 20 times the numerator as well. Okay, so you should get like 20 times 15 minus 20g. Okay, so then you got this guy. So we have, okay, I don't see anything right. So -g, right? So we got the slope for sure. Okay, I'm kind of confused a bit. So we got the -g plus 15 as my slope. So I can write the equation. And then that was the negative g plus 15 over 40 is the slope. And then I have the slope-intercept form. Okay, let me double check. So we got y plus 15 equals the expression. Okay, maybe I will not really replace the m, so for now. So let me clear that part. So like, okay, so we got the y plus 15 equals m times x plus 20. And if I want to pull the everything together, so you got mx, and then you got minus y, so you got 20m minus 15 equals 0. Okay, slightly better. So whenever you have an equation in the standard form, and then you can find the distance between a point to the equation, since the point I'm interested is 0, 0, so you plug 0 for x and y, so these two terms will cancel. So you end up getting 20m minus 15. And then this might be negative, so we want to make sure that's distance positive. Divide by the square of the coefficient of the x and y. So you got x squared plus 1. Again, if you've never seen this, this is another cool relation we should know. And then that's going to be distance, which is given the radius as 10. And maybe I can clean this a bit. So maybe I will multiply both sides by this number and square it, so you can cancel those bad numbers. You got 400 m squared, and then you got 300, so it will be minus 600 m plus 225. And it will give to 100 times this guy, so you got 100 m squared plus 100. Okay, so I hope that looks gonna promise. So subtract those, 100 m squared, which is 300 m squared, minus 600 m plus 125. I can divide by 25, so 425 is 100, so that should be 12 m squared, so that should be 24 m plus 5 is 0. And now, if we can like factor, we will probably try factoring that. But if we cannot, maybe we can just use the quadratic formula. But I don't really immediately factor, so I will just go with the quadratic formula. So the negative b is 24 plus or minus 24 squared is 576 minus 4 times AC, 12 times this. So 12 times 5 over 2 times 12. And you got 24 plus or minus. So like 4 times 520, that's 240, right? Let me double check. So that's 60, 240. If you subtract 240 from 576, so 576 and then 240, so you got 336 over 24. And then it looks like this is divisible by 4 because last digit is divisible by. So if I take the 4 outside, that will be 2. Let's divide by 2. So that should be like, let me double check, negative b, right? Yeah, I think I can divide by 4. If I divide by 4, let me divide by 4 first. So you got 12 plus or minus. So the 2's will cancel. So divide by 4. So you got 33 will be 8 times. And then you got 16, that's 84 over 12. And then this is also divisible by 4 again. So you can just divide by 4, take the 4 out of side. So you cancel those. So you got 6 plus minus root 21 over 6. Okay, this is the roots for m. But you know, the m was something we already had. What was the m, right? So we had the slope right here. So that was the my slope in terms of g. And now this is my what? M, right? Which is the slope. But you know, we want this number to be what? So we know the g, like g is equal to the 40 times m minus 15, right? No, actually, let me write this one. So like we have negative g plus 15 is equal to 40m. So I need to know which one of these two should be I chose. And if this is the case, so the g is equal to 15 minus 40m. Okay, so since you know m is positive, because the m is like 15 minus 40m is like negative. So g has to be positive because we are told that. So this is positive. If the g is positive and then 15 minus 40m is positive, then m has to be the negative, right? Otherwise, it doesn't work. So which means from this, the solution m has to be 6 minus root 21 over 6, not the positive version. Okay, and then we are looking for the g. So the g was what? G was just the 15 minus 40m. So we can just plug right here. So then the g is going to be 15 minus 40m. So maybe I can split those like 1 minus root 21 over 6. So that should be like 15 minus 40 plus 40 root 21 over 6. And then if you simplify, you get negative 25 plus 40 over 21 over 6. And then we want something as a fraction. So maybe we can take the divide by 2. That will be 20 and 3. So maybe that should be what we do. And if I take that, so you will get negative 75 plus 20 root 21 all over 3. I think that should be my answer. So we just need to now add the things. So the A, B, C, D. So the A was the number in front of the radical, which is like 40. I mean, no, 20, right? So that's 20. And then B was the number inside. So that's 21. And the next one is 75. And then we have just 3. So if you add those, you got 41, 44. So 119, right? I think that's what you say. Okay, so that was a bit challenging for sure. So let's see the next one. 21. So the set of numbers is called sum free if whenever x and y are not necessarily distinct elements of the set, x plus y is not element of the set. Okay. And then for example, 1, 4, 6 is, and one empty set are also sum free. Like basically it's telling you the x and y will be in the set, but not the sum. So like if you take the, let's say 1 and 4, that's 5, which is not in the set, which is good. 1 and 6 is 7, that's not in the set. That's good. But if you take 1 and 1, because you can choose x and y to be the same, so you got 2 is not in the set either. And then 4 and 4 is not in the set, so which is why this is good. But when you look at this one, 2, 4, 5 is not good because 2 plus 2 is 4, so that's not good. So what is the largest possible number of elements in this sum-free subset of first 20 integers? Like basically when you have something, let's say x, then when you add x to itself, so you get 2x, which means you cannot get the double of that number. So like if I want to start with 1, then you cannot get 2, so you can try 3. And the next one, like you cannot have 4 because we can add these two odd. You get 4, so next number should be 5. And then 5 is good, but 6 is not because 3 plus 3. So it looks like you can just keep adding the odd like this. You got 11, and then 13, 15, 17, and 19. So we got 2, 3, 4, 5, 1, 2, 3, 4, 5. So which looks like we have 10. So we can do this a couple different ways, but I think this is like one way of doing this. And we can even prove why we cannot do anything else, but that is choice C for this question. Okay, number 22. And this is actually a question I kind of like seeing a lot because whenever you have a circles touching another circles, that's a good reminder for us to remember the Descartes circles formula. If you do know that, it's actually a cool question. But if you don't, you can still connect the centers and write some sort of Pythagoreans, I'll say, and go from there. So let's try connecting the centers, and it has to go through the tangency point. So you will get something like this. Okay, so you know this is 1, and then this is 1. I guess this was 2, this is 2, this is 3, this is 3, this is 4, this is 3, this is 5, so which means this is 90 degrees. And the center circle right here is, let's say, has a radius of r. If you do know that Descartes basically telling us take the reciprocal of the radius, and then we take the radius of 1 over r, so that's the reciprocal, and then we take the reciprocal of all of these, which is 1 over 1 is 1, 1 over 2, and 1 over 3, and then this sum is being squared, okay, and now this is going to be equal to twice of the square of the reciprocal. So we got 1 square, 1 over 2 square, like 1 over 1 square, which is 1 over 4, plus 1 over 3 square, which is 1 over 9. And this is basically what we need to solve for. So we can get 1 over r. You can get 6, 3, and 2, which is 11 over 6 to the second power. And then times, if you multiply this by 9, so you got 36. And then you got 9, that's 45, plus that 49 over 36. I hope I did not miss anything so far. So we have the equation. So let's kind of, actually, no, I skipped the 1 over r squared. I should have 1 over r squared as well. Okay, so then that will make this guy a bit different. Plus 1 over r squared. So let's expand the left side because 1 over r squared plus when you multiply these two and double it, so you got 11 over 3r plus 121 over 36 is equal to 98 over 36 plus 2 over r squared. And if I clean everything one side, so you got 1 over r squared minus 11 over 3r. And then 98 minus 121, so it looks like you got 23 over 36. Okay, I'm going to multiply it by 36r. So if I do that, so 36r squared, So you got 36 minus 11 times 12r minus 23r squared is equal to 0. I'm going to multiply by -1. So you got negative like will be positive. So 23r squared plus 132r minus 36. Okay, that's a bit interesting. But I do hope for factoring because I don't want a quadratic formula. So let's try factoring this. Since 23 does not have really options, so you got 23 and r, and this is kind of a good option. So let's try that. So you got 23r, so maybe I should have actually 6 right here, because otherwise you cannot get 23 in the denominator, but I'm just guessing right now to see if this is factorable that way. To get 36, this should be 36. So then this has to be negative and this has to be positive because 23 times 6 will be 120 plus 18 and then minus 6. So it looks like 138 minus 6, which is 32. Yep, that's good. And then this is equal to 0. So the r will be just 6 over 23. Again, this is the another question that I actually seen even kind of similar one last year. So that was a really common problem. So if you didn't know the Descartes, the circles formula, you can try maybe taking the center and maybe make some right triangles and go from there. Or even chord bash might be useful. So I will say just try those and see if you can find another solution. But anyway, that was number 22.